Here it is, the Gemtronics GTX-5000 40-channel tube CB radio. Gemtronics. These radios are very hard to find in nice condition. As you can see, the front bezel is pristine. There is no rubbing, there is no missing lettering. Case is very nice too. And the inside is great too, as I'll show you in a minute. This is a tube radio, obviously, but it does have a digital frequency synthesizer which makes the radio capable of 40 channels, not 23, 40. Produced between 1976 and 1979, I think, maybe a little bit longer. Not too many were sold. They're pretty expensive compared to the 40 channel transistor CBs that were flooding the market. But just as now I should say, there was an audience for this in those days. People that loved tube CB radios, but that really wanted the 40 channel capability. Now let's have a look at the. It's very sensitive. It's a good radio. Now we got skip obviously today, propagation. It doesn't make much sense to make these videos when there is only noise. But today is a good day. Sensitive S meter. Controls pretty simple. We got a squelch. It's a good working squelch. We got a switch to switch the meter from S units to RF power. Don't know why they didn't combine that, but in any case, that's the way it works. We got volume control. The radio has good volume. We got fine tune for the receiver, not really needed in AM, but hey, it's there. And then we got PA and CB. PA stands for public address, so you could use the radio as a public address system, PA system. In your car you would do that, and this radio can be used in the car. It runs off 127 volts as well as 12 volts, or 13.8 I should say. It has a built-in DC-DC converter, and that's also done with transistors. I'll show you in a minute when we look at the back how that works. But very straightforward. We'll have a quick look in a minute what we get in RF power. Channel 6 never let you down. That's where all the big boys are. They call it the Super Bowl. And I was told that some of these idiots run powers as high as 10 kilowatts. They run complete broadcast stations, so we'll leave that for what it is. This is interesting. Now, if you listen to this, this is what CBers call the bees. And if you listen to it, you know why they call it the bees. Because it sounds like a bee, right? Now, the reason why you hear this noise is because propagation is so good right now that all these 4-watt radios also are coming through. But because they're all there and they're all the same power and they're all fairly weak, it manifests itself as a B sound. But the only thing that's important to know is when you hear this sound on channel 19 from all those truckers, maybe 1,000 or more right now who are pressing the button, if you hear the sound, it means propagation is very good, because this is not just the big boys, this is the 4-watt stations that you're hearing right now. So listen for the bees, and then you know that propagation is good. You know, I'm a licensed ham. I still listen to that because when I hear that, it tells me there is good propagation on 10 meters and on 12 meters as well, which are ham bands. Most hams aren't smart enough to try that out. But now I taught you that trick. Let's look at the transmitter performance. All right. Let's give it a try. We got the bird watt meter. worth 43. I got a 50 watt slug in it, so the full scale is 50 watts. There we have the monitor receiver, a Yaesu FT817. I have set it for channel 19. The radio is set for 19 as well, as you can see. We'll switch the thing to dummy load, so we won't bother anyone, although it's just a mess, probably wouldn't have mattered much, but nevertheless. And let's see what we get here. 1, 2, 3, 4, 5. Modulation sounds very good. 1, 2, 3, 4, 5. Testing modulation from the GTX-5000 on channel 19. Let's have a look at the power meter. It's about 5 to 6 watts, as you can see. 5 to 6 watts carrier. This meter does not show PEP, but usually when the modulation is about 100%, you get about 4 times that. So that's what we get. We can try a different channel. Let's try channel 1. Okay, that is 27965. That's where we are now. 1, 2, 3, 4, 5. It is basically the same performance. Power level is also the same. Close to 6 watts carrier. Now 4 watt is the FCC limit. This one puts out a little bit more, don't know why, because it is stock. I did not mess with the radio. But better too much than not enough. So channel 40, just to show you the complete picture here, that would be 27405. And what do we get there? 1, 2, 3, 4, 5, channel 40. 1, 2, 3, 4, 5. Works excellent. And that is the transmitter. Alright, quick look at the inside. That's really what we want to see, of course, for a tube radio. Here we have it. Now, I was starting to clean the chassis. It's quite a job, but as you can see underneath it looks like new. So I leave that the rest for the new owner. But for the rest, this radio is in excellent condition. They're hard to find in nice condition, these radios, like I said earlier. But this one is excellent. Just to discuss the tubes, this is the ECF80. That is the first oscillator and the RF preamp. I take that back, it's the RF preamp and the mixer. Here we have a second ECF80, which might be the oscillator, or maybe that's the mixer. In any case, first, this is the RF coil, this is the first IF, it's 9 point something. And then here we have the second IF, which is 455 kilohertz. This is a 6B86, that is the EF93. Second IF filter, here a second IF amplifier, same tube. Here the last IF filter. Here we have the audio amplifier preamp and the audio amplifier, also the modulator, the AM modulator. Here we have the transmitter mixer, the sidestep oscillator and the mixer. Here we got the driver, and here we got the PA. The PA is a EL84, which is the same as the modulator tube. And I don't know what the... I don't see it quickly, but it is a regular audio tube, which, like I said, is also used as a transmitter PA. Gives about 4 watt carrier, which is the maximum the FCC allows. That's about 20 watt PEP in AM. This one does a little bit more because I peaked the PA stages. I think it gives about 6 watts, 5 to 6 watts. Transformer, obviously, filter capacitor, modulator, transformer, and this is the transformer for the DC to DC converter. The radio is also capable of running on 12 volts, and then there is a solid state DC inverter that brings that to about 250-300 volts for the tube section. Now obviously this is a 40 channel radio, and the way they solve that is by putting in a relatively modern synthesizer, digital synthesizer, and this is the divider board. This is the mixer and signal processor board. So together they form the synthesizer, which makes it possible to have 40 channels for this radio. So it's like a combination of older technology with more modern technology. This is the channel switch. Now there is two switch wafers. One is for the synthesizer logic for the divider, programmable divider, and this is the logic for the decoder for the display. So there's two wafers, one for the display, one for the actual synthesizer. And judging the synthesizer switch, this is a radio, Japanese radio that was made by Cybernet. This looks like a Cybernet chassis. Now this chassis was used on many other radios. The most well-known one, the Robin, what is it? The Executive 240D. But in 23 channel version it also has been used on other versions, like the Lafayette Comset is a radio that used the same chassis, although it looks completely different from the front. But this is kind of a generic tube chassis, and like I said, the Japanese later converted it to 40 channels by adding a digital synthesizer, which is kind of neat. That is unusual. We'll quickly put the Robin next to it, then you can see what the deal is. Alright, that's what I was talking about. This is the Robin T240D. I'm still in the process of restoring this one, so it doesn't work, but it was just to give you an idea. As you can see, they're virtually the same radios. The only difference is actually the RF gain. The Robin has an RF gain. Here that is not the case. It's always set for maximum RF gain. And here we have a range expand, which is to give the audio preamp, the modulator, a little bit more gain, microphone a little bit more gain. But the fun part is this radio doesn't have that. Here it's just a meter, SNRF. But if you look at the diagrams, this one always has the range expander on, if you want to call it that. So what Robin did was just actually not increase the gain in the audio amplifier, but decrease it, and they call that standard. And then when you put range expand, you got normal gain, so it's kind of a gimmick. But nevertheless, interesting. External speaker and PA is a little bit different here. Here that is a toggle switch. But they're virtually identical, these radios. The front is a little bit different. The inside is, as you can see, this is the Gemtronics. Here we got the Robin. As you see, these radios are virtually identical. It is the same chassis. Here you can see a little bit better. And there's a slight difference. There is only one thing that is definitely different between these two radios. And that is the power cord. You know, the layout for this octal connector for the power cord is different for the Robin than it is for the Gemtronics. I have no idea why they did that, but if you would put a Gemtronics power cord on the Robin or vice versa, you're going to destroy the radio. It's funny, I've seen blogs on the internet where people are asking what is the wiring for the Gemtronics, and they say, well, just go to cbtricks.com and download the Robin D240, and then you know what the power cord is. That's actually not true. If you would do that, you would destroy your Gemtronics, so be very wary of that. You can find the schematic diagram for the Gemtronics on what is it? radiomuseum.org, I think it is. It is not a very good schematic, but it's good enough to figure out what the power cord wiring is, and there you will see the differences. But for the rest, it's virtually the same radio. I have no idea why they changed the power cord, and the rest is all practically the same. Does not make any sense to me, but I just wanted to show you what the differences is between these two, or I should say the similarities. Here a quick look at the component side of the radio, the bottom of the chassis. As you see, it's your typical chassis built tube radio chassis, and it's all there. This is the transmit receive relay. Here we got the 10.2 40 megahertz reference oscillator. It's used for getting to the second IF for the receiver, as well as a reference for the synthesizer. These are the transmitter stages. Here we see the receiver IF. This is the power supply section for the synthesizer, which works obviously at low voltage, and the tube section obviously works at high voltage. That's the supply part here. So basically the bottom of it. Alright, I had promised you a shot of the rear of the radio. I always find it interesting what radios look like on the back side. This is the transistors for the DC to DC converter I was talking about earlier. Now they're covered, that is because they carry a plus voltage, so you don't want to short them out. So there is a little protective cap over that, but the transistors are underneath that. ID plate, obviously, a warning is always a good thing. This is to set the S meter for 0. Now you want to do that when there is no signal coming in, because otherwise you will be zeroing out the noise level. For instance, here where I am, I have on this radio signal strength 223 for the noise floor, but when I remove the antenna jack, then it goes to 0. So you really have to set it for 0 without a signal, otherwise you make the meter too insensitive. This is a extra speaker, external speaker. Here we have the SO239 RF jack for the antenna, and here is the power jack. This is a octal plug, as you can see, and like I said earlier, this is not the same layout as the Robin 240, so don't make that mistake. You will blow up your radio. But through here you can either connect 127 volts AC or 13.8 volt DC, and on the schematic diagram, as I said earlier, that you can download from radiomuseum.org. There you can download the diagram for this particular radio, so don't make the mistake to look at the Robin 240. There are identical radios almost, except for this aspect. So please check that out and don't blow up your radio. But here it is, the back. Looks pretty clean. It's a compact, nice little tube radio. The Japanese did a good job. I always like this 40 channel version the best. So this is a great collector's item, it really is. Demonstration of the amplitude envelope on the oscilloscope. We got the radio, we got a signal strength meter, we got a attenuator, 30 dB attenuator, and the output of the attenuator goes into a 50 ohm terminated input for this oscilloscope. Let's see what we got. 1 2 3 4 5, 1 2 3 4 5. As you see, no flat topping and no overmodulation. The speeds nicely goes to practically 0 to twice the envelope, which is the definition of 100% AM modulation. The radio is equipped with an automatic gain control for the modulation, so it prevents overmodulation. Now it can be set with the potentiometer on the inside. Don't mess with it. If you mess with it, it's not going to be better, it's going to be worse. I know that the CB butchers like to crank that up, but the result is distorted modulation, not stronger modulation. So leave it alone, it's perfect as it is. This radio has textbook amplitude modulation.
Hey, Diamond Rio, you got a couple out there, man. complain about something. Oh yeah, but the thing about it is, you know, nobody likes a rat. Karma will come back to them there.
Alright, that was basically it. The Gemtronics GTX-5000 40-channel tube CB radio. And fairly rare. Don't see too many of them. Especially not in this pristine condition. One of the few 40 channels tube radios that were actually sold at the end of the 70s. And after that it was all transistor.
Give me about a half an hour, man. I'm trying to finish something up.
Thank you for watching this video.